While China and Russia quietly build their lunar presence, SpaceX may already be creating something bigger, faster, and more disruptive. This is an inside look at SpaceX's Moon Base Alpha. For decades, the moon was treated like a trophy, something to visit, take photos of, and leave behind. But today, it's something far more important. It's strategic, it's resource-rich, and it may decide who leads humanity into the next century. It's been over 5 decades since the last of the Apollo missions, and the moon is once again a target for space exploration. But NASA no longer has lunar exploration to itself. This time, our ambitions go far beyond collecting rocks and planting flags. Think of a permanent base, one that allows humans to live, work, and conduct research directly on the lunar surface. Let's bring it back a little. Only 12 human beings have had the privilege to walk on the moon, and despite the success of the US Apollo missions between 1969 and 72 to date, only 5 nations have landed on the moon, China being one of the most ambitious of the nations. Now, it will no longer be the sole preserve of national space agencies. Commercial companies also want a piece of the lunar action. Reasons for going vary from scientific knowledge and technological advances to the prospect of accessing potentially useful lunar resources and political or economic value. Here is a tip. If you care about staying ahead, subscribe now. A new chapter is unlocked, and SpaceX has its own vision for this bold new chapter: Moon Base Alpha. Technically, the moon base we're preparing to build won't be the first human base on the lunar surface. During the Apollo missions, astronauts established 6 temporary outposts. However, these so-called bases were more like short-term landing sites rather than actual infrastructure capable of supporting sustained human or robotic activity. To date, the only instances of humans living on the moon have occurred inside the Apollo lunar modules, where astronauts stayed for a few days at a time. During the Apollo 17 mission, one of the major challenges faced by early lunar crews was lunar dust, a substance that clung stubbornly to their suits and was carried into the cabin, where astronauts could smell and even taste it. The scent was described as similar to gunpowder. This fine dust is not only pervasive, but also potentially hazardous to human health. So, can SpaceX's moon base overcome the challenges of the past and become humanity's first true permanent outpost on the moon? Building a moon base from the ground up would require the efforts of hundreds of people, years of planning and development, and the transport of vast amounts of infrastructure to the lunar surface. Fortunately, SpaceX may not need to go through all that. They already have a multi-purpose vehicle, Starship, designed to carry both cargo and humans to the Moon and Mars, and, in SpaceX's long-term plan, could also be converted into a permanent lunar base. The concept revolves around repurposing the vehicle's large volume, particularly the empty fuel tanks, into robust space habitats. Even in its current form, its internal volume exceeds that of the entire International Space Station. Repurposing its fuel tanks would add even more habitable space, potentially rentable to other space agencies or commercial entities, to generate revenue and promote sustainable growth. The secret sauce of Moonbase Alpha isn't actually on the moon. It's in low Earth orbit, LEO. To get that 100-ton payload to the lunar surface, SpaceX has to master orbital refueling. For a single Starship to reach the moon, it requires a tanker campaign. Current estimates suggest it will take between 10 and 15 tanker launches to fill up one depot Starship in orbit. This gas station in the sky then transfers thousands of tons of cryogenic liquid methane and oxygen to the lunar Starship. This is a logistics feat never before attempted. Critics like former NASA Administrator Mike Griffin have called it extremely complex, but for SpaceX, it's the only way to break the tyranny of the rocket equation. By refueling in orbit, Starship leaves Earth's gravity well with a full tank, effectively starting its mission to the moon from zero, rather than struggling to carry all its fuel from the ground. Additionally, Starship's stainless steel material is an advantage as it is a well-tested material that can be modified for use in harsh space environments. Additionally, Starship was originally engineered to carry up to 100 people on extended missions, meaning its life support capabilities are already designed for long-duration spaceflight. The mission to convert the vehicle into a permanent lunar base is expected to take about 2 to 3 months. During this operation, 2 Starships, 1 crewed and 1 carrying supplies, will travel to the surface of the Moon. The uncrewed supply Starship will launch from Earth first, carrying all the necessary equipment, tools, materials, systems, and provisions required to construct and sustain the future base. The crew responsible for establishing the base will launch shortly afterward aboard a separate Starship. So, what's all the fuss about? Why go back to the Moon? That is because the Moon is no longer about exploration, it's about positioning. Whoever establishes a permanent presence on the Moon gains access to valuable resources like water ice and minerals, a strategic foothold for deeper space exploration, scientific discovery, technological advancement, economic benefits, and a first-mover advantage for future lunar territory. Unlike traditional lunar missions, which rely on tiny landers and limited payloads, Starship changes the equation completely. It's fully reusable, capable of carrying over 100 tons to the Moon, designed for both cargo and crew, and can be refueled in orbit. This is something revolutionary. This means that instead of visiting the Moon for days, humans can stay for months, and instead of building slowly over decades, entire base modules can be delivered at once. To understand why 100 tons is a magic number, compare it to the current competition. The NASA Space Launch System, SLS, which costs roughly $2 billion per launch, can only send about 27 tons toward the Moon. China's upcoming Long March 10, designed specifically for its 2030 crewed landing, is expected to have a similar trans-lunar injection capacity. SpaceX is aiming for 100 metric tons minimum. In a single landing, Starship delivers more mass than the last 4 decades of lunar missions combined. This isn't just more stuff, it's the ability to land heavy industry. We're talking about 3D printers the size of small houses, massive solar arrays that span football fields, and autonomous excavators. SpaceX isn't sending a tent, they are sending a factory. Moonbase Alpha would likely begin as a small research and logistics hub, but it wouldn't stay small for long. Because Starship doesn't just land on the Moon, it moves in. To understand why SpaceX has an advantage, you need to understand what Starship actually does differently. During the Apollo era, every kilogram mattered. Payloads were tiny, everything was custom-built, and every mission was disposable. Starship breaks every one of those rules. It lands vertically on the Moon. It carries massive prefabricated structures, and it can return, refuel, and fly again. Imagine this. One Starship delivers solar arrays. Another delivers pressurized habitats. Another delivers rovers, life support systems, and supplies. Instead of assembling a base piece by piece, SpaceX delivers it like freight. Apollo brought 2 astronauts for a few days. Starship brings dozens for extended missions. That's the difference between a visit and a settlement. The Moon is beautiful, no doubt, but just as deadly as it is beautiful. There's no atmosphere, no magnetic field. Temperatures swing from extreme heat to extreme cold. Radiation constantly bombards the surface. So, how do humans survive? The answer lies in engineering and location. Moonbase Alpha would almost certainly be built near the Moon's south pole, where sunlight is nearly constant and water ice is abundant. Habitats would likely be covered in lunar soil for radiation shielding, partially underground, designed for long-term habitation. Solar farms would generate power. Water would be mined from ice deposits. Oxygen would be extracted and recycled. This wouldn't be a fragile outpost, it would be self-sustaining. And that's the key difference between survival and permanence. Why spend billions on a base? The Moon is the Persian Gulf of the 22nd century. First, there is water ice. Located in the permanently shadowed regions, PSRs, of the South Pole, This ice is the gold of the solar system. It can be broken down into hydrogen and oxygen, literal rocket fuel. Moonbase Alpha would be the first gas station for ships heading to Mars. Second, there is helium-3. This rare isotope is nearly non-existent on Earth, but is embedded in the lunar soil regolith from billions of years of solar wind. It's the holy grail of clean energy. A single ton of helium-3 used in a future fusion reactor could provide enough energy to power a city of 10 million people for an entire year. With a value estimated at $4 billion per ton, the first company to mine the moon doesn't just win a race, they win the global energy market. Now, let's talk about the competition. China has been methodical, quiet, and extremely patient. Its International Lunar Research Station, planned with Russia, aims to establish a long-term robotic and eventually human presence on the moon. China's approach is state-driven, cautious, and slow. Russia, on the other hand, faces serious challenges such as aging infrastructure, budget constraints, limited launch capabilities. While both nations have ambitious plans, they lack one thing SpaceX has mastered: speed. Governments plan in decades. SpaceX operates in months. And that is what makes the difference. Here's the real reason Moonbase Alpha could outperform China and Russia. Cost. Starship is designed to collapse the cost of spaceflight. Reusability means launches become routine. Mass production means hardware improves rapidly. Failures lead to fixes. OT delays. SpaceX doesn't wait for perfection. It iterates. While government programs struggle with bureaucracy, SpaceX launches, learns, and launches again. China builds carefully. Russia struggles financially. SpaceX moves fast. And in space, speed isn't just an advantage, it's dominance. Moonbase Alpha isn't really about the moon. It's about what comes next. The moon is a testing ground for Mars, for deep space travel, for humanity becoming a multi-planet species. If successful, it would mark a turning point in history. For the first time ever, Earth would not be humanity's only home. Children would be born knowing that humans live beyond this planet, and the future wouldn't be limited by gravity. The first moon landing was a national achievement. The next one may be a corporate revolution. The next giant leap for mankind might not be made by a flag, but by a starship. So the real question is this: will SpaceX reach the moon before China and Russia build their bases? And should the future of space belong to governments or to companies bold enough to move faster than history? If you enjoyed this deep dive, like, share, and subscribe for more inside looks at the technologies shaping our future. Because the space race isn't coming, it's already here.